This flip video is going to be on the equations of motion and how we take something like this and turn it into something like this. And this will be in preparation for your exam on Thursday. So let's start with our easiest formula. We have, this is for calculating the average speed of an object moving at a constant velocity. So this is how the formula appears on the reference table. But perhaps you have to solve for distance, or maybe you have to solve for time. So let's start with the first one, distance. If I have this formula, and I want to get it solved for distance, well, I have to isolate d all by itself. To do that, I need to multiply both sides by time, which will get the times to cancel out over here, and I have time over there, and you end up getting d is equal to vt. A friend of mine used to say the way to remember that is driving to Vermont. But now let's say you want to get solved for t. See if you can do it, so pause the video, and then see if you come up with the same way. Try to do it by cross multiplication and division, so give it a shot. I think one way you can do it, and there's probably more than one, is do the same thing we just did before, is multiply both sides by t. Right now, and that now leaves you with d is equal to that. And now divide both sides by average velocity. So that's going to leave you with, I'll write it, let me move this a little bit. That's going to leave you with time is equal to distance divided by average velocity. So here's our first rearrangement of the formula, and then back up here was our other rearrangement. So now let's start with our acceleration formula, which says acceleration is change in velocity over time. Make sure you remember that's the units for acceleration are that. So let's start with just getting delta v by itself. So take a second to see if you can figure it out. Okay, so again, we go acceleration is change in velocity over time. So you would multiply both sides by t. That gets these t's over here to cancel, and you're going to be left with change in velocity is equal to acceleration times time. The units here would be meters per second. Right, so that's your first rearrangement. So let's say you want to get this rearranged for time. So again, take a second to do it, and then check your work with what I do here. We're going to multiply both sides by t. We're going to get those t's to cancel out. Then we're left with delta v is equal to at, which we just saw on the other side. And we're going to divide both sides by a. And you're going to be left with time is equal to change in velocity over acceleration. And the units for this would be seconds. Now it's important not to memorize the formulas. I'm just going through to show you how to do it. It's much more significant if you're able to rearrange them. The formula is this one. Okay, so we can rearrange this for three different variables. Let's first start with VI. Okay, this formula gives you a final velocity in meters per second. So take a second to see if you can rearrange it for VI. Okay, so if I start here, I think the easiest thing to do is just subtract AT from both sides. So you're going to be left with VI is equal to VF minus AT. And again, the units would be meters per second. We're talking about a velocity. So now let's rearrange this in terms of A. So let's see if you can do that. Again, pause the video and see if you can rearrange it, and then check with what I do. Okay, so the first thing I would do is I would subtract VI from both sides. That's going to give you VF minus VI is equal to AT. And then what I would do is I would divide both sides by T, and you're going to be left with A is equal to VF minus VI over T. Since this is an acceleration, the units would be meters per second squared. So that's your second arrangement. And this formula is the one that we just worked on, this one. The last arrangement is solving it for T. So again, pause the video and see if you can do it. So the first thing I would do is subtract VI from both sides. So that's going to leave you with VF, so I'm subtracting that. That's going to leave you with VF minus VI is equal to AT. Then you're going to divide both sides by A. So you're going to be left with time is equal to VF minus VI over A. And the units for time would be seconds. All right, so that's our third formula rearranged. So let's start with the displacement formula. This is actually a quadratic formula. We don't have to worry about that though. We're just going to deal with just certain aspects of it. So in terms of dealing with this formula, typically VI is going to be 0 if the thing starts from rest. So let's start with those conditions. If my object starts from rest, then you know that this whole first term goes to 0, and I'm left with just 1/2 AT squared. So let's rearrange this in terms of A first. Okay, so we have our 1/2 AT squared. So what I would do is I would multiply both sides by 2. That would leave me with 2D AT squared. And then I would divide both sides by T squared. And let me start a new page because I'm running out of room. Leaves us with this formula. A is equal to 2D over T squared. And the units for this, remember, it's acceleration, so it's meters per second squared. If I wanted it in terms of, actually let's solve it for terms of T. Remember our formula was this. So I'm going to multiply both sides by 2. Right, so that's going to give me 2D AT squared. Then I'm going to divide both sides by A, which is going to give me 2dA is equal to T squared. And then I'm going to take the square root of both sides. And so I'm left with T is equal to square root of 2D over A. And remember, those units are seconds. Now with that formula, we don't necessarily have to be able to separate out the variables by the quadratic. So these are the two I just showed you, the ones you need to know. The last formula we're going to deal with is the VF squared formula. Okay, so let's solve that for VI. Give it a shot, and then check your work against mine. Okay, so we have VF squared is equal to VI squared plus 2AD. So the first thing we'll do is get rid of the 2AD. And so now you're going to have VI squared is equal to VF squared minus 2AD. I should have written the minus 2AD there. And then what I'm going to do is I have to take the square root of both sides. And I'm going to be left with VI is equal to the square root of VF squared minus 2AD. So that's the first arrangement. Okay, now let's go to our arrangement for A. To do that, what I'm going to do is I'm going to subtract VI squared from both sides. So I'm left with VF squared minus VI squared is equal to 2AD. Then I'm going to divide both sides by 2D. So I'm left with my new formula, A It's equal to VF squared minus VI squared over 2D, and the units are meters per second squared. Let's go with the last arrangement, solving for displacement. It's going to look very similar to what we just did. So I'm going to start with subtracting VI squared from both sides. So that leaves me with a VF squared minus VI squared is equal to 2AD. And in this case, I'm going to divide by 2A. And I'm going to be left with D is equal to VF squared minus VI squared over 2A. And the units for that are going to be meters. Okay, so that's all those formulas rearranged that you're going to need for the upcoming test. Make sure you come for extra help and do lots of problems.